Okay, so here we are going to look at trig functions in the coordinate plane. We're going to take right triangle trig and we're going to extend it. So in a right triangle, we know we have some triangle here, and maybe we label it ABC. And then we get little a, little c, and little b. We know, for example, sine of angle A is the length of the side opposite of angle A over the length of the hypotenuse. And we know how to do this in a right triangle. But in a right triangle, angle A here can't be negative, can't be greater than or equal to 90 degrees. A and B must be acute angles in a right triangle. We're going to take this idea and extend it to angles bigger than 90 and even negative angles. We're going to be able to use any angle we want. So we're going to start with a coordinate plane here. And instead of calling these the x and y axes, I'm going to call these the A and B axes. So my horizontal distance will be A, my vertical distance will be B. And the reason we do that is we like for angle to be x. So when I say x here, I'm going to be referring to some angle from the horizontal axis. X doesn't mean this distance anymore. X refers to an angle. So let's just draw a right triangle here. Say we're in quadrant 1. Then we are going to define, this is a definition, say the sine of angle x to be, well, if I come over some distance A here and up some distance B, and we have a right triangle here, let's call our hypotenuse R, then we're going to define the sine of x to be the length of this side opposite x divided by the length of the hypotenuse, B over R. So it's literally just right triangle trig. Nothing fancy happened there other than I'm calling the angle x. That's just opposite over hypotenuse, nothing special. However, I'm now going to let x be even bigger. I'm going to let x extend into quadrant 2. So this will be my angle x. So opposite and hypotenuse, adjacent, none of those make any sense anymore. I can't even draw a right triangle that contains angle x. It's impossible. X is like 110 degrees. It doesn't even fit inside a right triangle. There is no opposite. There's no side over here. What we're going to do is draw what we call this reference triangle against the horizontal axis. So remember, we called this our A axis. So I have some A here and some B here. So this is the point A comma B. I could even write that up here. This was the point A comma B right there. And again, we'll call the length of the hypotenuse R. So we're looking at this right triangle that doesn't even contain x. And we're going to say, by definition, still, sine of x will be the length of B over R. And we want to note here, just make a note. Think of these as coordinates. Here in quadrant 2, A is a negative number and B is a positive number. Look, I've gone backwards on the horizontal, up on the vertical. And R is always going to be positive. R is our hypotenuse and it's always positive. So I can talk about sine of, say, 110 degrees. I'm allowed to talk about that now. And what that means is I draw a 110 degree angle right here. I draw a triangle that lives against the horizontal axis, a right triangle. And then somehow I find out what this length right here is that we're calling B compared to this length R. And the sine of 110 will be this length divided by that length. And for now, we could just type that in our calculator. We can keep going. I can go into quadrant 3. So my angle X now will be this angle here that doesn't even fit inside a triangle. So we're talking angles like 200 degrees, bigger than a triangle. So how are we going to define sine of that angle? Well, we're going to draw this little reference triangle here that lives against the horizontal axis. And again, my horizontal line here will be A, the vertical will be B, and the hypotenuse will be R. And it's the same definition. Sine of X will be B over R. B over R. Now note here in quadrant 3, like we can look and see A is some negative component. I've got this point here, A comma B. A has to be some negative number. I've gone backwards. I've gone to the left. Oh, that's less than 0. B is also negative. I've gone down. To get to that spot, I would have to go backwards and down. And R is always going to be positive. So if I take a negative divided by a positive, sine is going to be negative. Sine will spit out a negative number here. We could do this in our calculator real quick. I could do sine of anything that's in quadrant 3, maybe 200 degrees. Sine of 200 spits out a negative number. And I can keep going. I could go into quadrant 4. So I have some angle here that goes all the way around. That's angle X. We're talking like 315 degrees. Then I draw this reference triangle that lives against the horizontal axis. The hypotenuse is always R. We're going to call the horizontal component A and the vertical B. And by definition, it's always the same. Sine is opposite this reference angle over R, hypotenuse. So in every one of these, we can still think opposite over hypotenuse. But by opposite, we don't mean this angle X. Angle X doesn't have an opposite. Opposite this reference angle that lives against the horizontal axis. So alpha here, we call the reference angle, and we want opposite over hypotenuse. Here, this would be angle alpha, opposite over hypotenuse. Alpha. That was the ugliest alpha ever. I'm calling this angle here against what you would think of as the x-axis. Opposite over hypotenuse. Notice here in quadrant 4, A is positive, B is negative. See, I went over some positive horizontal distance, down some negative. B is negative. R is always positive. R is the hypotenuse, and it's always positive. In this case, sine of X is going to spit out a negative number. And we could keep going. I could take X to be around the circle 37 times. I'm not going to go 37, but around the circle a bunch of times, and then land right here. So X is like 4,000 degrees maybe. I don't know. We've gone around the circle a whole bunch of 360s plus a little bit extra. Then what is sine of X? Sine of X will be, well, we draw in this reference triangle, and it will be B over R. Whatever this length is over this length. Sine of X is always the vertical component over R. The Y value, if you want to think X and Y, over R. So, now we have this function, this brand new function sine of x. Let's call it f of x equals sine of x. Functions have domains. The domain is the set of all allowed inputs. What kind of x's am I allowed to use here? I can use anything I want. Negative infinity to infinity. You can take sine of any angle. We could even have negative angles. I could take x here to be rotating backwards. So x might be negative 30 degrees. I could do that. Sine of negative 30 degrees. That doesn't fit inside a right triangle. You have negative angles in a regular old right triangle. Now I'm saying by this new definition, I can. If that's a negative 30 degrees, I would have to find the ratio of this side to that side. And we'll do that problem later. The answer, by the way, is negative 1/2. So x can be anything. I can take sine of any angle I want. What about my range? Functions have a domain and range. Well, what's the biggest value sine can be? So sine, let's say here in quadrant 1, is the ratio of this length to this length. Sine of x is b divided by r. How big could that possibly get? Well, if I start really small, say if I start with a little tiny angle right there, b is very small, r isn't changing. And as my angle gets bigger and bigger, b is getting bigger, r is not changing. Imagine we're just rotating around. Imagine we're on a circle of radius r. So we've got all these different triangles we can draw. Where does b get the biggest? Right here. At 90 degrees. Right there, b and r are the same thing. What's anything divided by itself? 1. B will never be bigger than R. So the biggest sine can get is 1. And we just said a minute ago, we can have negative values. If we're right here, B would be negative R. Negative R divided by R would be negative 1. So my range, smallest to largest, negative 1 to 1. So sine is a function. You give it an angle, it spits out a fraction. You can put in any angle you want, positive or negative, and it will always spit out a fraction between negative 1 and 1. Okay, let's do the same thing for cosine. This will go much quicker now. I have any angle in any quadrant. Here's x, here's A, B, and R. We define cosine of x, cosine of the angle x, to be the horizontal component over R. Sine goes with the y value, if you want to think like that. Cosine goes with the, I'm going to put in quote here, the x value. Remember, we're not calling this x. X is the angle. So cosine goes with the horizontal. Sine goes with the vertical. It's the same idea. I could be in quadrant 2. So here's my angle x. Maybe it's like 100 degrees. I draw this reference triangle against the horizontal axis. Not like this. I see this happen all the time. If we've got some angle x, people want to draw this triangle. That's wrong. Draw the triangle so the right angle is down here against the horizontal axis. Then it's literally, we just use SOHCAHTOA. There's my little reference angle, the one that's in this triangle, adjacent over hypotenuse. Cosine of x is the adjacent in the reference triangle over hypotenuse. And notice here in quadrant 2, My angle here is in quadrant 2. A is negative. B is positive, but I'm not even using B. Who cares? R is positive. R is always positive. Cosine's going to be negative here. In quadrant 2, cosine will spit out negative angles. Okay, what about, so if I have this entire function, f of x is cosine of x, that guy has a domain, and it's literally the same stuff we just wrote. Domain is all real numbers. I can take cosine of any angle I want. Range for the exact same reasons. Range is -1 to 1. You plug in any angle into your calculator you want, take cosine of that angle, it will always spit out an answer between -1 and 1, including -1 and 1. Okay, we could do the same thing for tangent. So if I've got, we'll draw it over here. Here's some A, some B, and some R, and this is angle X, but angle X might be anywhere. Then tangent of X will be from the reference angle opposite over adjacent, B over A. Now we are going to run into issues here because sometimes A might be 0. Anytime we're on this vertical axis, like if my angle looked like this, I'm straight up and down, A is 0. We can't divide by 0. Tangent has domain issues. And that's any time my angle is 90 or 270 or all the way around 360 plus another 90 or backwards -90. Any of the 90s or 270s are going to make A equal 0, and we can't divide by 0. So tangent will be undefined at those points. Okay, now we tend to write that in radian mode instead. So if we have this function, f of x is tangent of x, then we say our domain is all reals except x is not allowed to be any pi over 2, any of the odd pi over 2s. Here's 1 pi over 2. 2 pi over 2 would be okay. A's not 0 here. B is 0, but so what? You can have 0 on the top. 3 pi over 2. Here's 4 pi over 2. This would be 5 pi over 2. That's bad again. Any odd pi over 2. And then we'll talk about this later once we get the graph. Let's just write this down for now. But the range of tangent is all real numbers. And we'll see that once we get the graph. Okay, now, what's important here is knowing where everybody's positive and negative. So here's my recommendation to you. Memorize this. All students take calculus. Memorize that. All students take calculus. I'm going around the circle here from quadrant 1, 2, 3, 4. All students take calculus tells you who's positive in which quadrant. Of the big three, we really only care about sine, cosine, and tangent. We'll get to secant, cosecant, and cotangent later, but they're easy once we get the big three down. Sine, cosine, and tangent. ASTC tells you who's positive in each quadrant. So in quadrant 1, all of them are positive. All three. Sine, cosine, tangent, they're all positive. In quadrant 2, only sine. Meaning cosine is negative in quadrant 2, and tangent is negative. Here I'll say all three positive. In quadrant 3, only tangent is positive. Meaning sine and cosine are both negative in quadrant 3. And over here, all students take calculus. C, only cosine is positive. The ASTC tells you who's positive. Only cosine is positive. The other two are both negative. So let's just pick a random angle. Let's say x is 117 degrees. That angle will look like this. Here's 117 degrees. I'm going to have this reference triangle here. Here's my little A, my little B, my little R. And I can just look at the picture and see, okay, A is a negative number. B is a positive number. R is always positive. And I could work out, well, sine of x is B over R. B is positive, R is positive. That has to be positive. Cosine will be A over R. A is negative. Look at it. That's a negative. So cosine must be negative. And tangent is B over A, opposite from the reference angle, opposite over adjacent. B is positive, A is negative. A positive divided by a negative is negative. So I could go through all that, or I could just say in quadrant 2, all students take calculus. Sine's going to be positive, the other two are negative. And we can see that. Let's type those in our calculator. Sine of 117, positive number. Cosine, negative. And tangent, a negative. Okay, and that's a good place to stop.